So what we are going to do in group 2, or attempt to do, is to try to, by comparing the digital pharma model with the traditional model and the properties of technical structure and the boundaries of the product, try to explain give you some insights in terms of FTO and IP management. Okay, so I'll start by answering the first question, which is really kind of the introduction to this, explaining what are the structure differences in the structure of the product and what are the boundaries. So as explained in by group 1 and then out by Alex, in traditional pharma, the product is really based on identification or on one compound. So it's the identification of this active molecule. So it's either a molecule or a family of molecules that works for a specific application. So it's, in terms of boundaries, it's relatively well defined. It's the molecule, so it's one technology, one product. So the boundaries are very well defined. I think also, as I was hinted by group 1, when we enter digital pharma, this becomes much more fuzzy, because we start to have a product that might have a hardware, often has a hardware component, a user interface, as well as a number of software interfaces. So the product is much more complex. Exactly what is trying to be packaged is not always very simple. So it becomes very hard to determine precisely what are the boundaries of the system and how they can be determined. And so with this, I pass on to my colleagues that will tell us about.
Yes, thank you, Anna. Yes, as Anna touched upon, this change of system boundaries results in a drastic change in the kind of patents that you can use to protect the invention. So in traditional pharma, we have this classic fortress monopoly. We've invented a new molecule and we can protect it in its whole, and then essentially we sell the molecule and we can prevent other people from selling the molecule as a whole. So that's where we see in patent type 2, we have this patent towards just an insulin composition, and that directly protects what we're offering. However, when you move this to digital pharma, we have these really, really much more complicated systems. And with that, you have many different parts, all of which interact and all of which can be separately protected. So we start from really the core system. So we've got an example of a patent here, which is towards just a sensor. And although this is just one patent, you can imagine that nearly every part of this system can be individually protected. And then this core system is protected in an interface, which is to do with how you actually control the insulin pump. And then even broader than that, you need a way of managing all of your data. And so you've got broader patents that, or not broader patents, but related patents that also deal with those kinds of innovations that we have within our property, within our product, so that we can offer better consumer benefits, and that's how we protect them. And you can see there's this total shift from just your complete protection of the whole scope of what we're offering to really this complete melding of loads of interrelated systems.
We are working more about a product, a composition. So the dominant IP classes where we had few dominant IP classes, and the top applicants were more about pharmaceutical industries. So it was easy to search for patents or to compare or to file even patents. And you can see in the graph that the number of patent applications were decreased with the years. In the digital pharma, we have other types. And as you have said, now we are more with intangible results with the digital protection. So we have more and more dominant IP classes. And especially with the patent type 4, when we have a lot of data processing and data management related to patent. So we have more and more IPC classes. And as you are seeing, the patent application are increasing each year. And for the patent type 4, we have about 100 times more patent application than for the other types.
Now to the FTO process, of course, this very big shift from traditional pharma to the digital pharma has certainly also a big influence on the FTO process, because of this shift from one patent landscape to a very big other patent landscape that has to be monitored. And here we can see 8 steps of a traditional FTO process for the traditional pharma. So first step is to disassemble the research item into attributes and elements. So this step really involves breaking down the drug or product being developed into its component parts, such as chemical structures, active ingredients, and any other relevant attributes. Then after that, a selection of a regional coverage of the search. So depending on where the drug is being developed and where it will be marketed, and it's important to focus the FTO search on the relevant geographical regions to really narrow down the effort and the time and resources to invest in during the FTO process. As a third step, then selection of special databases, for example, structured databases. So in addition to traditional patent databases, there may be specialized databases or resources that can provide additional information on relevant patents or prior art. So as said, for example, the structure database could be used to search for similar chemical compounds or molecular structures that might be relevant for the FTO analysis. In the fourth step, really to specify the application-oriented classification symbol. So IPC, I think everybody of us is aware of IPC classification. And by specifying this relevant IPC codes, the FTO search can really be narrowed down to focus on patents that are most relevant to the drug being developed. So also here, limit down the resources and time that's needed for analyzing the FTO results. And then with the 4 last steps, so define keywords, create search strings, search, and evaluate the search results is very basic. So I think everybody has a picture about that. And these 8 steps, then sum up to this traditional FTO process in traditional pharma. And on the next slide, we will see how this will change in the digital pharma.
The development process for business models and products differ in the traditional pharmaceutical industry and new digital pharma approaches, especially with regard to development periods. And this has an impact on the performance on the FTO. These differences are shown in the timeline of the development process and derive the implications for the performance of the FTO analysis.
For the last task, we will compare the timeline of the FTO process between traditional pharma and also digital pharma. On the left-hand side, for the traditional pharma, you could see that the key point is that the products that were once introduced to the market will not be changeable. So the entire process is a little bit more like a waterfall kind of a development process. And also once before market launch, there will be this big FTO check, which is performed as a snapshot. So this is only one example, but maybe different companies do it differently at different snapshot or time frame. And we call this that the FTO is being checked because it's being done at a snapshot. On the other hand, on the right-hand side, if you see the digital pharma, this business model is being continuously developed, expanded, or modified, because this is a co-creation between product management, R&D, and also IP. And that means that it is not sufficient that FTO is only done one time. The entire development process is more like an agile methodology or process. So the FTO would be something like a time scale process you can see on the screen. So it extends all the way, and it's always being done as a continuous support process. And that is also why the reason it is being listed as an FTO process is being established rather than it is being checked. So this sums up our presentation for Group 2. Thanks, everyone.